Alright, so let's continue from where we ended. If you can remember very well, we looked at double angles where we said we have this identity for sine 2a, which is equal to what? Here we said this one is equal to 2 sine a, then cos a. This was our first identity. Then the second one, if you remember very well, we said we have cos. Let me use x. We have cos x, which is equal to cos squared x minus sine squared x, and this one was the second identity. Now from this one here, if you remember very well, we came up with two identities because we know to say that sine squared x plus cos squared x is equal to 1. So if you decide to take this one to the other side, you are going to find that what are we going to have? We are going to have cos 2x, which is equal to 1 minus sine squared x minus this sine here, sine squared x. So if you do the assumption, we are going to get 1 minus 2 sine squared x. Then here we have cos 2x. I think you remember this one. The second one was, let's say you take this one here to the other side, what are we going to have? Definitely we are going to have 2x, which is equal to 2 cos squared x, then minus 1. So these are the two identities that you can derive from this one here. Now for today, let's try to look at power reducing identities. So for power reducing identities, we are going to use now the same identities that we have, especially this one for cos. So let's try to make cos squared x the subject of the formula and see what we are going to have. So making cos squared x the subject of the formula, meaning we are going to take this one here to the other side. So if we take this one here to the other side, here we are going to remain with 2 cos squared x. So let me just put 2 here. Then there we are going to have, or here we are going to have 1 plus cos 2x. So this is what we have. So we are making cos squared x the subject of the formula. Here I can divide by 2, even here by 2. So therefore cos squared x is equal to 1 plus cos 2x divided by 4. So this is the first identity for power reducing identities. So you need to take note of this one here. So apart from this one, let's try also to look at other identities. Alright. So we know to say that sine squared x, or let me just say this one here, sine 2x is equal to what? Let me use the other one so that you understand. We have cos 2x, which is equal to 1 minus sine, which is 2 sine squared x. I think you remember this one here because this one here we obtained it from. So I think you can agree with me that we also have this one here, cos 2x is equal to 1 minus 2 sine squared x. So what we are going to do here is, we know to say that we have cos 2x, which is equal to 1 minus 2 sine squared x, and we want to make sine squared x as the subject of the formula. So what are we going to do? We are going to take this one here to the other side and take this one here to this side here, so that this one become positive. So what are we going to have? We're going to have 2 sine squared x, and this one is going to be equal to 1 minus cos 2x. Right, so here I'm just going to divide by 2. Even here I'm going to divide by 2, so that this one and this one cancels each other. So therefore sine squared x is going to be equal to 1 minus cos 2x divided by 2. So now one thing that you need to understand here is that these identities, they are similar. Now the only difference here is the positive and the negative sign. For sine squared x, here you are going to have a negative. For cos squared x, here you are going to have a positive, but the rest, they are similar. So what are we going to do? So we know to say that cos squared x is equal to this one and sine squared x is equal to this one. Now what about tan? Let's see. So for tan, what I'm going to do is, we know to say that tan squared x is going to be equal to sine squared x divided by cos. Being on this one, you can agree with me. Now what is sine? We know to say that sine is this one here, so I'm going to say we have 1 minus cos 2x divided by 2. Now we also have this over here, so let me just change the color. So I'm going to say over, then we know to say that cos is this one here, which is 1 plus, or let me not say this one but this one here, it is 1 plus cos 2x then divided by 2. And I think if we say let's multiply the numerator by half and also the denominator by half, what we are going to obtain here is let me not say by half, let me do this so that I don't bring confusion in my calculations. So what I'm going to do here, I'm going to flip. As you can see here, we are having a division, so a division changes to multiplication, but for this one here we are just going to maintain the same thing. So we are going to have 1 cos 2x and then divided by 2. Now for this one here, they are going to reciprocate, so meaning on top, if we introduce a multiplication here, 2 is going to be the numerator, and down here we are going to have 1 plus cos 2x. This is what we have. So therefore this one and this one, they are going to cancel each other, and here we are going to have 1 minus cos 2x divided by 1 plus cos 2x. So this one is very, very important. So this is another identity for tan squared x when it comes to the power reducing identities that you need to know. So let me just give you an example or example so that you see the application. Right, so the first example is going to be find what sine to the power 4x is. How can you find this one here? So this is our first example. How can you go about this one? So you know to say that you only have the identity for the reducing power as sine squared x. But one thing that need to know here is that this one here can be also be written as open bracket sine squared x then squared. They are just the same, because if you multiply 2 multiplied by 2, you are going to get 4. So these they are just the same. Now if you remember very well, what is the identity for sine squared x? The identity for sine squared x, you're just going to have a negative here, but everything is just going to be the same if you remember very well. So here we are going to have 1 then cos 2x divided by 2. Then when it comes to cosine squared x, here you need to have a positive. But remember, here we have a squared, so we can do likewise. Alright, then from there, what are we going to do? So here we can distribute. If we distribute these two here on this one here, and also this one on this one, what are we going to have? So for the first part, on top we are going to have 1 minus cos 2x squared. Then on the down part here, we know to say 2 to the power 2 is 4. So we can just say 4. To make our work easier, let me factorize 1 over 4. This 1 over 4 is coming from this one here, we are having a 1 here, and this 4. So if I say 1 over 4, then what am I going to remain with? I'm going to remain with 1 minus cos 2x. Now remember we have a 2 here, so let me just also multiply again by 1 minus cos 2x. Then from there I can do the computation. So here we have 1 over 4. So I can start doing the computation here. 1 multiplied by 1, I'm going to. From there we have 1 over 4, then 1 minus. So these they can be added. So we are going to get 2 cos 2x, then plus cos 4x. Then from there now we are done, because we know to say that these they can't be added because the angles here they are different. Here we are having a 2x, here we are having 4x. So that is how you're supposed to answer that one. Otherwise, let's try to look at the half angles. So these half angles, they're just going to come from the same identities that we have talked about, especially double angles. We know to say that the identity for the double angle of sine, it is this one. You're going to agree with me. This is what we have, isn't it? But if we introduce the half angle here, meaning it's more like we are multiplying the same angle that we have by half, okay, throughout. This is a 2, then we have a sine, then x divided by 2, then here we have cos. So this looks big, so we have cos, then open bracket x divided by 2. So this is what we have actually. But you know to say that these they can cancel each other. Then what are we going to have? We're going to have sine x, which is going to be equal to 2 sine open bracket x divided by 2, then cos x divided by 2. I think this one is just very simple to come up with this one. So from there, let's make one of these the subject of the formula and see what we are going to have. Okay. So let me just do this. Okay, so let me just do this. So this is what we have, isn't it? But we know to say also on part of cos that cos 2x is going to be equal to what? It's going to be equal to cos squared x, then minus sine squared x. So even this one, when we divide by 2 throughout, what are we going to have? We're going to have cos x, which is going to be equal to, here if I do the assumption, let me just do this. Here we're going to have 1 minus 2, then sine squared x divided by 2. I think this is what we are going to have, isn't it? Then again, we are going to have cos x, which is going to be equal to 2 cos squared x, then minus 1. Okay, so here we're supposed to have a 2. This is what we are supposed to have. and these identities, they are just coming from the same from this one here, this one and this one, they are coming from this one here. So now let's make this one here the subject of the formula and see what we are going to have. So this one is also an identity that you need to understand, and once you do the manipulation here, you are going to have this one here. So this is our first identity, but I'm going to focus on this one here because it is very easy for us to make this one here as the half angle. Okay, so let's start with the first one, which is this one here. Alright, so as you can see here, I can just take this one here to the other side and take this one to this side here. So this one is going to be positive as 2 sine squared t, then open bracket x divided by 2. And this one is going to be equal to 1 minus cos x, as you can see here. So if I divide throughout by 2, what am I going to have? So this one and this one, they are going to cancel each other. Then I'm going to remain with sine squared t, open bracket x divided by 2. And this one is going to be equal to 1 minus cos x divided by 2. Now we want to make sine as the half angle in terms of the subject of the formula. So what are we going to do? As you can see here, we're having a 2. So to eliminate that 2, I'm going to introduce the square root to both sides. Now square root can be both positive or negative, so I'm going to say plus or minus. Okay, then this is going to be sine x divided by 2, and this one is going to be equal to plus or minus root of 1 minus cos x divided by 2. So as you can see here, I think these identities, they look similar. Now the only difference, as you can see here, is that here we are having a square root, and also here there is a missing 2. If you remember very well the identity for sine squared x, it was something like 1 minus cos 2x divided by 2. So as you can see, they are looking similar. The only difference is that here we are having 2x, but here we are having x, and here we are having a square root, but here we don't have. So it is like that. So it is very, very important to understand. Even we can derive the same identity, this one here, from this one. If we can just say we divide by 2 as the half angle, and then we introduce the square root to both sides like this, then I think this one is just going to be very simple and very easy. So similarly, we are going to get the same one, which is this one here. Okay, so that is how we are supposed to go about that one. But remember that here you need also to divide by 2, because we are dealing with angle, so that you remain with x as we are dividing here by 2. Okay, so let's also try to look at the other identity for sine as the half angle. So this is the identity for the half angle of sine. Now let's try to look at for cos. So for cos, we need to take which one? We need to take this one here. So let me just start from here. Okay, this one. So here we're having a minus, here we're having a 2. Alright, so we want to make cos x divided by 2 as the subject of the formula, and I think here we're having a squared, right? So how can you go about this one? Similarly, you get this one here, you take it to the other side. So we have 2 cos squared, open bracket, x minus x open bracket, or open bracket, x divided by 2, then close, and this one is going to be equal to cos x plus 1. Now cos x plus 1 is same as 1 plus x, isn't it? So let me just arrange them in order by starting with 1, because they are just the same. So we can divide throughout by 2, even here by 2. Then what are we going to have? We're going to have cos squared d, open bracket, x divided by 2, and this is going to be equal to 1 plus cos x divided by 2. So similarly, as you can see, we're having a 2 here, so I can just introduce the square root. Even here, remember, square root can be both positive or negative, so we're going to, of course, open bracket x divided by 2, which is going to be equal to plus or minus root of 1 plus cos x divided by 2. So this is the identity for cosine, which is the half angle of cosine. Now let's try to look at the identity for tan. You know to say that tan is equal to what? Tan x is equal to sine x divided by cos x. I think you remember this one. But here we are looking at tan as in terms of tan open bracket, then x over 2. Right. Now, before we look at that one, let's do this. We know to say that when it comes to the double angle of tan, it looks something like this one here. Then here we're going to have 2 tan a, then over 1 minus tan squared a. So we want to make this one here as the subject of the formula. Now before we make this one as the subject of the formula as tan, we need to divide by 2. So if I divide by 2 here, even here by 2, even here by 2, what are we going to have? Here we are going to have tan a, and this one is going to be equal to 2 tan open bracket a divided by 2, then over 1 minus tan squared a divided by 2. So this is what we have. Now I want to make this one the subject of the formula, so let me just do this. So what am I going to do here? Okay, let me multiply. Okay, so if I multiply, what am I going to have? Without wasting much of our time by multiplying, let me just do this. We know to say that tan is equal to sine divided by cos, and we know what cos is and we know what sine is, so it's just very easy for us to put those things. So we know to say sine is which one. Here you just need to put a what? A minus. So for sine you're going to have a root of 1 minus cos x, let me just do this, cos x, then divided by 2, then O of, for cos it is this one here, you say root of 1 plus cos x divided by a 2. So as you can see here, if we do the assumptions, what are we going to have? This one here is going to be on top, and this one here, they are going to interchange here, isn't it? So we are going to have something like, since they are having the same root, so we can just say root of 1 minus cos x, then O over by 2, then multiply by root of, we have 2, then O over by 1 plus cos x. So they are having the same roots, isn't it? So this one and this one, they can cancel each other, and then here I can multiply. So let me just do this. So if I multiply, I'm going to find that I'm going to have plus or minus root of 1 minus cos x, then O over 1 plus cos x. So this is what we have. Now from these assumptions you can also come up with other identities if you want. So you're going to find that if you do the assumption, you're going to find that you're going to have something like sine x divided by 1 plus what? 1 plus cos x. Then you can also have something like 1 minus cos x divided by sin x. So these are the things that you need to know so far. So let me just give an example which is concerning this part here, then you can call it a day. Okay.